Okay, today we're going to talk about absolute value inequalities. Okay, so one thing that we should remember is that absolute value is related to the distance from zero. Okay, so that's just like if I had the absolute value of -3, that would be 3 because that's how far -3 is away from zero. So that's just a little flashback. Okay, so today what we're going to do is we're going to make sure that you guys can solve absolute value inequalities, graph the solutions, state the solutions in set notation and interval notation, and understand how to read an absolute value inequality, and how to write an absolute value inequality from a graph. Okay, so woo, we got a lot to do. Okay, here we go. Okay, so for example one, when we solve absolute value inequalities, we get an interval of answers, right? So we're not going to just get one answer. Like this one's an equation, right? So we get one answer, okay? But we're going to have an inequality, okay? So what we're going to do is this says all of the values x that are less than 3, so all of these values x that are less than 3 away from 0. So if we put 0 in and we do 1, 2, 3, we would have a point here, and 1, 2, 3, we would have a point here. So this would be 3 and -3. So obviously if I'm at -3, I am 3 units, so I'm not less than 3 units. And if I'm at 3, I am exactly 3 units, so not less than. So all of these points in here are less than 3 units away from 0. So that's technically what my solution looks like. So how do we break that down algebraically? Well, we know that the inside value is going to have to be less than 3, and you can see that right here. Okay, but we also know that the inside value could be related to the opposite number, -3. But when we do an opposite number, we're going to change the inequality sign. So we're going to have greater than -3. And you can see that this is how we are creating this and, right, intersection or and situation. Okay, we can also write an and as it can be less than 3 and greater than -3. And's the only one that you can kind of write in a sandwich like that. Okay, let's talk about, so this would be more like set notation, right? Let's talk about what it would look like interval notation. Well, if we start walking here, the first value we get to is -3, but we're not including -3, so we use the parenthesis, and then we keep using these in here. And then we get to the last value, which is 3, and we also don't include that. So this guy is interval notation. And this one is set notation. Okay, so we need to be able to do either one of those and then graph. And you can see that when there's an and, we're doing this purple region, which is the overlap region, where it was blue and pink. But we started out with that graph because we know how to read an inequality, an absolute value inequality. So when we look at this one, the difference between this one and the last one was that there's something with the x inside the absolute value. So when there's something with the x, this is saying all of the x values that are greater than or equal to 3 units away from, and this is going to be 2. Because you see over here, when we have absolute value of x, that's the same as absolute value of x minus 0. So the difference between x and 0. This is the difference between x and 2, right? So 2 is going to be our middle guy, and we're going to go 3 units in both directions to get the endpoints. So this guy will be 5, 1, 2, 3, and this guy will be -1. So when we're talking about being greater than or equal to, we're definitely including those boundaries. And then we're going to be, the distance is greater than, so that means I'm getting further away from the 2. All of these have a bigger distance than 3 away from 2. And so you can see how we can look at what our our inequality is and be able to graph this. Now, obviously, the orange are not the values, right? Okay, so let's see how we would do this algebraically again. So we would start with the inside, x minus 2, and we would say greater than or equal to 3. Now, since the distance is getting greater than, that means an or. So if we have a greater than, we say or, and if we have a less than, we say and, okay? And then we'll also do inside with the opposite value, but when we do the opposite value, we have to change the inequality. Okay, so we have these two things. So the first one, we add 2, and we get x is greater than or equal to 5. That's this guy. And because it's or, we're taking everything, so we don't have to do it above the graph. And then we do the other one, add 2, and we get x is less than or equal to negative 1. And so you can see that that's this guy. Okay, and so what we're doing is, for set notation, we're going to say all the x's such that x is less than or equal to negative 1 in union with or x is greater than or equal to 5, okay? So you can say this or the word or. And then for interval notation, we start walking over here and we notice that we start using it immediately, right? And so we're going to go from negative infinity to negative 1, including negative 1. And then we don't use another point until right here. So we include the 5 and we keep going on to infinity. We don't ever include infinity. And so since this is an or, this is union, right? So that would be the interval notation. But you guys can see that the graph that we originally got is the same exact values as what we have already graphed on our graph. This one's a little more difficult because this linear term has a coefficient, right? So what we're going to do is we are going to not translate this so easy. So we're just going to set up the problem and solve it. So that was when we were taking the inside and doing greater than 4. Now, since this is a greater than, that means it's getting further away, so it's going to be an or. And then the other side is going to be the inside, and then the opposite value, which means that we need an opposite inequality. Okay, let's solve the first one. Add 2. We have 3x is greater than 6. And then divide by 3. And x is greater than 2. So if we were going to look at values here, actually, let me erase this. We're going to say here's 2 is our superstar, and we're going to go greater than 2, and it's an or, so we're going to take everything. We're not going to overlap, so we can go directly onto the thing. And then we're going to have plus 2. I might need to change my pencil after this. 3x is less than negative 2. Divide by 3, divide by 3. We have x is less than negative 2 thirds. Now, I really definitely need to change my pencil because I can't even read that. X is less than or equal to negative 2 thirds. That might be a little bit too small, but. And so when we write this in, or so when we go on to the graph, we're going to go to here's 0, and then we're going to go to here's negative 1. So negative 2 thirds is about right here, let's say. And actually, this is horrible. Let's just graph this a little bit better. Okay. So that's 2, this is 1, this is 0, this is negative 1, this is negative 2. So when we're talking about our value negative 2 thirds, we're going to be about here. And we're including it. Oh, no, we're not including it. Sorry, I wrote it wrong here when I changed my pencil. So we are not including it. So we're going to open up at negative 2 thirds, and we're going to be going less than. So all of these values are less than that value. Okay, so we can rewrite this in set notation as all the x's such that x is greater than 2 or x is less than negative 2/3. We can also write this in set notation with the right side as negative infinity to negative 2/3, not including the 2/3, in union with 2, not including the 2, to positive infinity. So that could be our interval notation. So you can see how that one's a little bit harder to see because we don't really have that middle. Okay, so let's do another one. So we still want to focus on getting that absolute value alone. Like our first problems had the absolute value alone, but this absolute value is not alone because it has a -5 there. So what we're going to do is we're going to get it alone first. Add 5 to both sides, and adding 5 doesn't change the inequality at all. So we have 2x plus 2 is less than 20. Okay, cool. Now let's set up our two statements. We have inside is less than the value. Now since it's less than, we're going to have an and, right? And so then we're going to have 2x plus 2 is, we're going to do the opposite of the value, which means we take the opposite of the inequality. Okay, so let's see what we've got here. Subtract 2. We have 2x is less than 18. Divide by 2, x is less than 9. Okay, we have x is less than 9, and we have subtract 2, 2x is greater than negative 22, divide by 2, and we're going to get x is greater than negative 11. Okay, well this is great, but remember this is an and, so we can actually, for our set notation, put it kind of in a sandwich, putting the lower value here and the upper value here. And that could be our set notation. Let's see what the graph looks like. So we're going to be at 9. And we're going to be greater than or, less than or equal to 9. And then we're going to be at negative 11. And we're going to be greater than or equal to there. And because it's an and, we need the overlap. So we'll be open on the end, and we'll be in between these two. Now, how can we write this? We are going to write this as not including negative 11, because that's the first thing that we would get to. And then we don't include 9, because that's also the last thing. So that will be your interval notation. The first one was your set notation. Okay, let's look at the next one. This is a little bit different because our absolute value is alone, and then we have this negative number here. And when you have a negative number here, when the absolute value is alone, you have to stop and think every single time. This guy is always positive. No matter what our x is, this value is always positive. So this says that my positive value is greater than or equal to negative 9. Now, is that always going to happen or never going to happen? Well, that's always going to happen. A positive number is always going to be greater than a negative number. So we are now going to be looking at, actually just not negative 9, but negative number, right? So we know that this is always going to happen. So we're actually going to be able to fill our graph in all the way because we know this is always going to happen. So no matter what our x is, this is going to happen. And we can go from negative infinity to positive infinity. And we can also say x such that x is all real numbers. Okay, so that's great, but how would we know it if we just kept going and we didn't recognize that? Okay, well, if we set up our two situations, we have 2x plus 1 is greater than or equal to negative 9. So we do exactly what we see, and then we do 2x plus 1, the inside, and we use a 9 now, and we're going to be changing the inequality. So this is going to be an or because it's greater than. Okay, so now we're going to subtract 1, and we have 2x is greater than or equal to negative 10, and we get x is greater than or equal to negative 5. Now, if we looked at this, if we put negative 5, let's say like right here, and we said we're going to be greater than or equal to, that means we're going to be able to take all of these values as solutions. If we do this one and we subtract 1, we're going to get 2x is greater than or equal to 8. And so when we divide by 2, we'll end up to get x is greater than or equal to 4. So that means we will, oh, we didn't change the inequality, did we? Bad, bad, bad. Let's go ahead and change that inequality. Because remember, when we change the sign, when we change this value, we also have to change the inequality. So we changed the inequality, so this is actually a less than. Sorry about that. And there you go. Okay, so we're going to go to 4, let's say is right here, and we're going to say that it's going to be going from here and less than. Well, this is an or, and so that means we're going to take everything. And let's actually just put that underneath so that it looks a little bit nicer. Right? So you can see how we did use everything. We used all of this for green, and we used all of this for red. So when we look at everything that we used, it was the orange. It was from negative infinity to positive infinity. So we did go from here all the way to here. So if we didn't recognize it right away, we would see that. Also, we just can't make those mistakes like I just made. Okay, so let's do the next one. Well, this absolute value isn't alone because of this negative 5 being on the outside. And that negative 5 is multiplying the absolute value, so we're going to divide. But the problem is when we divide by a negative number for an inequality, we have to change the inequality. So we're going to end up to get x plus 2 is less than or equal to negative 5. Okay, cool. So there's that negative again on the other side once we get it alone. Okay, so what does it say? This says I'm a positive number, and I'm going to be less than or equal to a negative number. Is that ever going to happen? That is never, ever going to happen. So that's no solution. So when we look at our graph is done. We're not putting anything on our graph. But let's see how we can notice it. So when we do this, we would take the inside and do the same inequality, the same name or number, and then we would have the inside, and we would use the opposite number, which means we have to use the opposite inequality. And because this was a greater than, or sorry, because this is a less than to start out with, we are going to say that this is a and, which means we have to overlap, okay? So we go from when it is alone. All right, let's check this out now. Okay, so if we were solving this, we would subtract 2, x is less than or equal to negative 7. So let's say negative 7 was right here, and we went less than or equal to negative 7. So the only part of our solution has to be in that area because it has to be in both of the areas, right? So we're going to subtract 2, and we get x is greater than or equal to 3. But wait a minute, 3 is over here. And so if I'm going to be greater than or equal to 3, I'm here. Do these overlap at all? No, they don't. And that's why there's no solution. Okay. So that's why there's no solution. Okay, so now let's go and think backwards for a second. We're going to write an absolute value inequality for this solution. So let's think about what this solution looks like. It goes from 40 to 50. It's open because there's no equal sign here or here. And it's in between because and is the only one that can be written like that. So it's greater than 40, boom, and less than 50, boom. So that's where it's in between. When we go to write an absolute value, we are talking about all of the points that are away from a certain value. So we're going to go right in the middle here. What is in the middle between 40 and 50? Well, we know that it's 45. But if you didn't know it, you could have taken 40 plus 50 and divided it by 2 to get the 45, because that's how you're going to get the mid value. Okay, so that's our mid value. So our x is coming, doing a distance away from that middle value. Okay, now, because it's getting closer, we are going to use a less than, right? And it's also an and, so we knew it was going to be less than. but we're not including these boundaries because like you see here, these were not included, so it's not going to be included here. And then let's see how far away the middle is from the exterior. Can you guys see how there's 5 units here and 5 units here? That means all of our points are going to be less than 5 units away from 45. And so that's how we're going to write our inequality. Oops. So what does that mean? This guy is our middle. And this is the distance from the middle to end point. Okay. Wow, there's a different one. But guess what, you guys? We're still going to go to that middle value. So if we did 7 plus 11 divided by 2, we would have gotten 9. So 9 is our middle value. So x minus 9. The distance of any of these points in here or in here are going to be greater than or equal to, because it's equal to because they actually included the boundaries. What value? Well, how far is it from the middle to the end point? It is 2 on both sides, and you can see how it's 2 on both sides. So this is going to be a 2, and we are done. Okay, so I do want to just remind you about one thing, is that when you are trying to get this absolute value alone, you notice that on this one, we have an absolute value on this side, and we have an absolute value on this side. But do you see how this is the exact same absolute value? So this is kind of like saying 5w plus 4 is less than 3w plus 8. Well, we just need to get the w alone, right? So what we are going to do is we are going to get that w on one side and then move the value over. So when we do that, we haven't divided by a negative or anything. So we have 2w is less than 4. And so we divide by 2, and we get w is less than 2. So what was our w? Our w was x minus 2. So this is x minus 2 in absolute value is less than 2. So just a little reminder that you're going to be looking for like terms when you have two inequalities. Okay, I hope this helped you guys. Take care.